Stonehenge, one of the world's oldest structures. Its foundations predate the Great Pyramids. It is one of mankind's most ancient mysteries. Why is it here? Is it a temple? A burial ground? A place for sacrifice? Or could the mystery of Stonehenge be revealed in its builder's desire to explore the unknown heavens and touch the universe? Using the cutting-edge computer-generated imagery that takes us into deep space, we'll also go inside a virtual Stonehenge to see what the ancients saw and push this prehistoric marvel to give up its age-old secrets. Ancient mysteries, shrouded in the shadows of time. Now, can they finally be solved by looking to the heavens? The truth is up there, hidden among the stars, in a place we call the universe. The mysterious circle of stones called Stonehenge sits on a southern English plain, inside an earthen bank 5,000 years old. It was built over 15 centuries, begun by Stone Age farmers and herders, later completed by groups of successor peoples with sophisticated engineering skills. What drove them to build it?
What is Stonehenge? People have said that it's a giant temple, a wonderful monument sitting out in the Salisbury Plain where thousands of people could have come thousands of years ago to worship what? Gods? We have no written records. We take what we can from what we see and attempt to find out what it is.
What we see are the ruins of what was once a complex array. Could this structure, made of earthly rock, actually have been devoted to what takes place in the sky?
Watching the bright sun come up every day, the moon come up and change its shape throughout the weeks and the months, must have been quite a show.
Was this the Hubble telescope of its time? The first clue to the mystery may come from the sun. Every June, huge crowds gather at Stonehenge in a strange dawn ritual. It's the first day of summer, the solstice, longest day of the year. The people stare intently at a giant boulder called the heel stone.
What is remarkable about the construction of Stonehenge is that on the first day of summer, if you stand at the center of the monument and orient yourself towards the heel stone, then as the sun rises, you'll see essentially the sun come up just over the heel stone.
The precision to which this occurs year after year seems miraculous. Is it just a coincidence? Or did the ancient builders put the monstrous heel stone in just the right place to mark this day's sunrise every year?
It's outside of the ring. It's over 200 feet outside of the ring. It is 16 feet tall. It's probably got another 4 feet in the ground just to keep it stable, and it weighs 35 tons.
Was Stonehenge a sun temple with its focus at the heel stone? Do other stones point to the sun as well? The ruined monument we see today is incomplete. So the answers may lie in just how the giant stones were originally arranged. The main ring was a series of vertical slabs topped with heavy cross pieces. These lintels, as well as the uprights, were made of sarsen stone, a type of sandstone common to the area.
The sarsen circle is 180 feet across, 30 stones. Average weight can be anywhere between 20 and 40 tons. This is as large as a fully loaded cement truck. This construction task boggles the mind even today.
Inside the sarsen ring was a horseshoe arrangement of heavy stone arches, each piece weighing up to 50 tons. They're known by a deceptively forbidding name, the trilithons.
Trilithon just means 3 stones. 3 stones in this configuration. So 2 giant stones have been stuck into the ground with another giant stone then carefully placed on top.
To work out the link between the stones and the sun's changing path through the sky, you would need to visit Stonehenge every day for a year and place cameras in dozens of locations. But now there's a better way to look at Stonehenge from every angle, through the power of state-of-the-art computer graphics.
So in the simulation, we're present day, summer solstice sunrise. We're camming out, coming up over the monument, taking a look at its present state, advancing the sun as well. Shadows come across the surface and looks beautiful.
Professor John Philwalk heads up Idea Lab at Indiana's Ball State University. It was started as part of a $40 million project to use computers to visualize what our eyes cannot. Massive processing power immerses us in the ancient monument to decipher the mysteries of the silent stones.
Come into the sarsen ring, and we can take a look at the trilithon in the back, the main one. Thread the needle there. Can maybe spin around so we can see the features out there.
Using exact measurements of the stones taken by archaeologists, the computer's camera can move around a precisely reconstructed virtual Stonehenge.
The simulation is as accurate as can be. We have an accurate model, it's positioned accurately, and the data is also accurate. So what you're observing is precise.
Astronomical data compiled by NASA adds the positions of everything in the sky seen from the stones, just as if you were standing there. And by typing in a date and time of day, we board an electronic time machine that carries us to any moment in the past, present, or future. Watching the sunrise position change from month to month is effortless.
At this point, let's advance 1 month and see what happens. You can see the sun roughly framed by the sarsens there.
If we place the computer's camera in the center of Stonehenge, one thing becomes immediately clear. Your eyes are drawn to the horizon. Modern man pays little attention to the horizon. In our cities, it all but disappears. But for ancient astronomers tracking the sun, the horizon was a key reference point.
If you want to do astronomy simply, it's really hard to find things in the middle of the sky, to accurately locate them when they're directly overhead. But the horizon is a great place to try and get an accurate measurement of how things are changing on the sky.
Ancient astronomers could see that the sun rises and sets at different places on the horizon during the year. Because the Earth's axis is tilted, the northern hemisphere leans away from the sun in winter, making the sunrise seen from Stonehenge farther south. In the summer, the tilt is toward the sun, making the sunrise farther north.
When it rises on the first day of summer, the sun is as far north as it ever gets. Its position, in fact, may have been so important at Stonehenge, the central axis of the entire site points directly at it. But other stones mark the sun too. Take, for instance, the massive trilithons.
And each one of those appears to be a site for an event on the horizon. So for example, I can turn to one of the trilithons on the sunset of the first day of summer and watch the sun set right through the middle. And the sunlight will come through like a dagger right into the heart of the monument, right to where I'm standing.
But the summer sunrise over the heel stone has always seemed the most important marker. It's in line with a ceremonial approach called the avenue. The crowds face northeast, looking down the avenue to witness the event each year. But new evidence now suggests that the true main event at Stonehenge plays out in a totally different direction, in a completely different month. For thousands of years, the monument we know as Stonehenge has defied definition. But today, many believe it was an early astronomer's site. Was this a prehistoric observatory with a spiritual connection to the cycles of the universe? Exactly what was it its builders saw? The annual arrival of the crowds, celebrating sunrise in the Northeast on summer's first day, support the notion that this was the main event here. But new evidence turns this theory upside down. It suggests that astronomer priests conducted their most sacred rites in the other direction. A high-tech laser scan in 2011 revealed something totally new about the main Sarsen circle.
The Starsons seem to have been very, very carefully worked to look their most beautiful on that approach from the northeast and as you go into the monument, not looking from the other direction.
But what happens as we do look in that other direction? The sun is behind us. The stones cast their shadows ahead. Were the Stonehenge builders sun worshippers who warned us, look away from the powerful God? Or could it be that the crowd is not only facing the wrong way, they are here on the wrong day? If we spin forward in time, half a year of sunrises and sunsets have gone by, and we reach the moment when the sun again appears directly in front of us. It happens in December, on the first day of winter, when we see not the sun rise, but the sun set. Only one leg of the largest trilithon still stands, but in antiquity, it fully framed the breathtaking event. Was the brilliant winter sunset an object of special worship?
You walk up to a church. You don't get into the church and then turn around to see the altar behind you. The sacred stuff is ahead of you. And by that same argument, you might expect that the sacred stuff at Stonehenge is going to be ahead of you to the southwest.
The new discovery upends our assumptions. If winter sunset was most important, what other secrets of the universe are hidden within Stonehenge? For answers, we must push past the stones, pointing to the sunrises and sunsets that have dominated observations here. Outside the main Sarsen circle were 4 station stones laid out in a rectangle. Their positions strongly suggest they were meant as sightline markers to something. But what?
If you actually look at the sides of that rectangle, they just miss the stones of the Sarsen monument. Now, only 2 of these station stones are left now, but if you had all 4 of them and you looked along one side, you'd have just seen one corner from the other.
To solve the mystery of the station stones, we returned to the computer lab. We set up the virtual camera behind one stone and aim at another across the long side of the station stone rectangle. We turn day into night, and suddenly we see the moon. As it sets just behind the distant stone, the secret begins to reveal itself. The station stones may point to the strange travels of the moon.
In any given month, you'll see the moon do what the sun does in a year. It goes to the north and goes to the south.
The moon itself does not travel back and forth across the horizon. What we observe is the travel of the places where the moon rises and sets every day. One back and forth cycle takes place every month. With the station stones pointing to lunar positions and other stones aimed at the sun, some researchers and scientists now believe Stonehenge was designed for a dual purpose.
Right from the beginning, it was a luni-solar observatory or temple or monument to track the sun and the moon positions on the horizon.
But moon tracking is far more difficult than watching the sun. How could Stonehenge's astronomers have understood the complex cycles of the moon? Even today's astronomers have trouble visualizing how lunar motions in space translate into the moon's march across the horizon as it rises and sets on Earth.
Think of yourself in a rocket ship out in space, looking at the Earth and moon. We know the Earth is rotating on a tilted axis, but at the same time, the moon revolves around the Earth in an orbit that has a tilt of its own. But to understand how the moon looks to us from Earth's surface, I actually like to turn the picture around with the Earth on its side and the moon at its southernmost point on its tilted orbit. If we zoom into Earth's surface and look at the horizon, we can see why the moon would appear to be rising in the east, but also, for now, off to the south to some degree.
Seeing the moon in the southeast, the Stonehenge astronomers would next have watched for it to reach the north end of the horizon.
The moon takes about a month to go around the Earth. So in half that time, about 2 weeks, the moon is at the other side of its orbit. Now, if we go back out into space, it looks like this. But to see how it looks from Earth's surface, we have to swing our rocket ship all the way around to the other side of the planet. When we do that, we can see the moon rising in the east again. But now it's off to the north by some amount instead of to the south.
But in aiming their stones, the builders of Stonehenge may have also discovered a subtle secret in the range of the moon's motion.
The remarkable thing is, over a period of about 18.61 years, this range actually changes. So after about 9 years, it'll decrease a bit. And then in another 9 years, it'll go back to what it was before. So the range of lunar risings is actually changing like an accordion, sliding back and forth over time with a very well-defined cycle.
Over the course of its monthly swings, the moon will reach 2 extreme north-south positions in its narrow range and a different pair in its wide range. 4 extreme positions in all. And these are the targets at which Stonehenge's builders apparently pointed their stones. The lunar connection showed up in 1961, when Boston University astronomer Gerald Hawkins did the first computer calculations of sightlines at Stonehenge. His findings turned the ancient ruin into a symbol of mankind's quest to connect to the universe. Hawkins' conclusions remain controversial, but many scientists still respect the accuracy of his work.
I don't think anybody doubts the integrity of his surveying work and his calculations, and certainly some of that was duplicated, again, not just by others, but by Hawkins himself.
But could a culture without writing, a people with only oral traditions, have built up the knowledge to develop such a keen understanding of the moon and its motions?
It really is an issue of how long that cycle is. A cycle that's, say, around 18 years long still is not so long that it couldn't be passed on orally from generation to generation.
The 18.61 years in the moon's cycle may have figured in a bizarre numerical code that remains one of Stonehenge's most enduring mysteries. It is only one of many on our journey to uncover Stonehenge's true purpose. Like the mystery of the missing rocks, holes in the ground where stones have disappeared. We are separated from the builders of Stonehenge by 5,000 years or more. How can we possibly understand what they really meant to do so long before modern science began revealing the nature of the universe? The achievement of the ancient Britons is awesome. But is there enough left of Stonehenge to tell us the whole story?
What we see of Stonehenge is just half or less of what Stonehenge really once was.
Fortunately, Stonehenge hides some of its greatest mysteries underground, where signs of its many missing stones survive.
There are marks there of things that are no longer there. We have to speculate. So what you can do is you can scrape off the surface to get to the chalk bedrock. To set these stones into the landscape in Stonehenge required making a socket down into the chalk to keep these giant big stones steady. Those sockets are still there.
While some sockets held the big rocks, others held wooden poles. And there are hundreds of them. Were these astronomical markers? Along with the stones that still remain, they would have represented the advanced technology of their time. In the California desert, advanced technology of our own time may well become a puzzle for the future. 5,000 years from now, if all other clues have disappeared, what might people think of this?
Wow, look at that thing. It's amazing.
What is that?
I would imagine a future archaeoastronomer would fairly quickly assume it's some sort of ceremonial site. They would see a monumental metal structure. Maybe it functioned as some sort of sundial, maybe a place of gathering since there's no other habitation in the area.
All I can think of is look where I am standing. I'm standing in a huge desert. I've got a horizon 360 degrees around. It just feels like it's a monument to the sky because that is where my eyes are concentrating, is the huge sky that I'm seeing above me.
Modern astronomers, of course, can identify it instantly.
This is really a state-of-the-art 25-meter or 82-foot across dish-shaped radio telescope.
This modern observatory conceals a clue about the mysterious holes in the chalk beneath the turf at Stonehenge. In radio astronomy, scientists constantly adjust their telescopes by sighting distant ultra-bright galactic cores called quasars to calibrate their readings. Did the Stonehengers go through a similar tweaking process?
There are a number of holes that have been dug into the gap in the ditch and the bank that surrounds Stonehenge.
The holes are among many that held wooden posts, easier to move than the giant stones.
What's interesting is that they're on that main alignment that we know is critical to Stonehenge because it's the rising of the summer solstice sun, it's the setting of the winter solstice sun. We've got this beautiful alignment. So what are these holes? I gotta wonder if perhaps this was fine-tuning the positioning of markers inside and outside the monument.
But 4 holes hidden beneath the turf near the heel stone may have aimed not for the sun, but the moon. They show how Stonehengers might have tried to find a place for a wooden post that would point to the moon when it rose at the farthest point north it ever reached on the horizon. At Idea Lab, computer experts dial in the coordinates for their virtual Stonehenge to show how the ancient observatory may have been calibrated.
The ancient astronomers knew generally the most northern position of the moonrise, but they needed some means of fine-tuning that.
By placing wooden posts in the 4 holes, Stonehengers may have expected one of them to be close to the most northern moonrise. Virtual Stonehenge computes the moon's position and reveals the secret.
At the 4th hole from the position of the Saracen Circle center, we actually do see a precise alignment.
Who were these people, apparently so intent on tracking the sun and moon?
What we're seeing here is the transitions from the old Stone Age to the new Stone Age. And the essential development of the new Stone Age was human beings domesticating themselves. They were staying in one place and they were starting to farm.
These semi-nomadic farmers and herders were the first to start building at Stonehenge. They dug the circular ditch and bank around 3000 BC, perhaps even earlier. An opening in the northeast faced the summer sunrise. Over the next 1,500 years, successor tribes added the big stones, arranging and rearranging them into the array whose ruins remain today. If astronomical alignments were in fact built into Stonehenge, why was tracking the sun and moon important?
So many other cultures worship the sun and the moon as gods. So it's not a huge leap to then assume that the people of Stonehenge were also worshiping the sun and the moon as gods.
Early man watched the sun and moon to keep time for thousands of years before Stonehenge. But here, the counting of the days and years may have been an ancient sacrament.
The sky was the first clock. But in many ways, Stonehenge and the monuments like it were a way of creating a culture that ritualized time in some sense.
Over 15 centuries, Stonehenge's builders dug holes, hauled stones, shifted them around, added some, subtracted others. Was this the realm of ancient astronomers? Or was it the lair of a secret cult in a long-lost religion, with its faith founded in science? The enduring mystery of Stonehenge may rest not with its massive rocks, but in the cosmic patterns of the universe. sight lines between the stones align so well to the sun and moon, it seems like an ancient observatory. But at a time when human cultures were dominated by strange gods and superstitions, did Stonehenge's farmers and herders achieve some of mankind's first scientific discoveries?
Agriculture was a technology, but it couldn't be separated from the sense of the mythic, of the sense of the religious, the sense of that there were sacred powers being invoked every time you planted seeds in the ground. So the idea that all that was happening here was religion is a mistake, just like saying all that was happening there was some kind of proto-science is also a mistake. You couldn't separate them out for these cultures.
Without written records, the stones are our only evidence of the monument's connection to the universe. Today, we think of astronomers as scientists, precision observers who attack the mysteries of space with precision instruments. Did they inherit the legacy left by the ancient astronomers and their stones?
All of these are actually precision built for their technology 5,000 years ago. That's the reason why some of them are still standing today. They were that well put together.
But just how precise was this precision-built monument? The sun and moon sight lines among Stonehenge's rocks are accurate to about 1 degree.
There's a simple trick we astronomers use for estimating 1 degree in the sky. If you hold out your pinky finger at arm's length and look at how wide it appears, that's about 1 degree. Now, the sun and the moon are each about ½ a degree in size, so your pinky finger is about twice the width of the sun or the moon.
In today's world, what we call precision is much more demanding.
A degree 5,000 years ago was probably good enough for what they were trying to do. These days, we talk about locating things in the sky to accuracies of fractions of an arcsecond. And an arcsecond is a few thousandths of a degree.
But at Stonehenge, was 1 degree enough? Thousands of pilgrims each year will swear that the sun rises directly above the heel stone. But 1 degree accuracy gives them some wiggle room. As the virtual Stonehenge demonstrates, if the sun and the heel stone don't quite line up, a simple step to one side is all it takes to make it good enough.
To see the sun rising from Stonehenge over the heel stone today, you just go to the center of the monument and wait for the sun to come up, and of course it'll do that. And if you're off to the side a few feet, well, it'll be off a little bit, but it'll be close enough for most people because they're at the solstice and they're at Stonehenge. And that's what matters, because the sun is coming up and people are charmed by the convergence of all of these details.
Precisely observing the sunrise at Stonehenge is complicated by the slanted path the sun takes through the sky. When the sun first breaks the horizon, it is just to the left of the heel stone. Rising on a slanted path, it travels up and to the right, eventually appearing over the heel stone like a golf ball on a tee. The summer sunrise alignment has troubled observers who point out that today's heel stone is tilted and once stood taller. In addition, when we punch in a summer sunrise from 5,000 years ago, our computer simulation shows the sun rising even farther to the left. Does this seriously challenge the precision of Stonehenge?
What most people don't realize is that there was a companion stone, almost certainly, to the heel stone.
It is another one of the monument's missing stones. The chalk hole in which it stood was discovered in 1979, when a ditch had to be dug for a local telephone line. Archaeologists excavated ahead of the construction crew, and a long-hidden secret of Stonehenge was revealed. Its existence may solve the puzzling discrepancy surrounding Stonehenge's accuracy.
We don't know for certain the two stones stood together, but it seems highly likely, given the symmetry of things. These stones would have stood symmetrically. Midsummer sunrise would have risen exactly between them.
Accuracy in observing positions of the sun and moon is the domain of space. But the Stonehengers may also have sought precision in probing the mysteries of time. The cycle of the sun was one tool, and the moon even better.
In terms of tracking time, the moon may have been more important to early peoples than the sun. Because what happens with the moon? The moon goes through this remarkable change in phases, from new, to where it's completely invisible, to full and back again.
The moon's cycle of phases takes 29.5 days, a time span that shows up at Stonehenge in the 30 Y holes and 29 Z holes. The holes were discovered in 1923 and surround the main stone ring. By counting 29 days in one month and 30 in another, the early astronomers kept pace with the 29.5-day lunar cycle. But counting the various rings and rows of stones and holes at Stonehenge drives us even deeper into its mystery. Why are there 19 stones in one arrangement? Why are there 56 holes in another? Could these numbers hide an ancient code with the power to predict future events in the universe? The sky and Stonehenge appear to be silent partners. No user manual exists because the Stonehengers had no writing. Still, they may have left us a secret astronomical message encoded in numbers. Consider the number of 4 groups of stones and holes: 19, 29, 30, and 56. What could these numbers mean?
These are numbers that only describe the periodicities that can be associated with one unique astronomical object, and that is the moon.
While the 29 and 30 Y and Z holes represent the lunar month, 19 small blue stones inside the big Sarsen circle represent the moon's long-known metonic cycle.
Let's say we have a full moon on July 4th of this year. Well, next year, the moon won't be full on July 4th. It'll be some other phase. To have a full moon on July 4th again, you need to wait 19 years. And that's the metonic cycle.
But the mystery of a moon-based code goes even deeper at Stonehenge. There's another hidden number in a large outer circle formed by the baffling Aubrey holes.
The Aubrey holes are named for John Aubrey, who in the 1600s was one of the first people to notice these funny indentations outside the stone circle at Stonehenge. They are a set of 56 pits. They're evenly spaced in a perfect circle, just inside the ditch and bank.
The fact that the holes number 56 hints at what may be Stonehenge's most controversial theory.
They've been thought by some to be part of an astronomical computer, that the 56 holes could be used to mark the 18.6-year cycle and 56-year cycles that underlie eclipse prediction.
What could the number 56 at Stonehenge have to do with predicting eclipses? If 56 is a lunar number, it must relate to the full moon. Because without it, there can never be a lunar eclipse.
Suppose the Earth is here and the sun is over there. You can have a full moon only when the moon is on the opposite side of the Earth relative to the sun. So it would be over here. Now, if the moon, Earth, and sun are exactly in a straight line, the Earth will cast a shadow on the moon. And that's called a lunar eclipse.
The Stonehenge eclipse computer, with its 56 Aubrey holes, may have worked like this. After one lunar eclipse, the challenge was to figure when it would happen again. After 19 years in the Metonic cycle, the moon was full on the same date, but at a slightly different position in the sky. When would it be not only full, but in exactly the same spot, lined up with the Earth and Sun for an eclipse? The number that works is not 19, not 56, but 18.61 years, the same time it takes the moon's back and forth trip on the horizon to expand and contract. It's a way to pinpoint the moon's position, and so predict the mystical arrival of a lunar eclipse.
During a total lunar eclipse, the moon can turn a deep orange color or even blood red. So that must have been a pretty compelling, even frightening event for ancient peoples who worshipped it.
But the Stonehengers, without writing, could not deal with fractions. Counting to 18.61 was impossible. And that is where the 56 Aubrey holes come in.
The number 56 is also the sum of the number 19 and 18 and 19.
So by using the 56 Aubrey holes to count 19 years, then 18, then 19 again, the count per year averaged less than 0.5% from 18.61. The very number needed to track the moon's exact positions on the horizon and predict danger periods when eclipses might occur. Without physical or written evidence, the eclipse connection at Stonehenge is not widely accepted. Skeptics believe numerical clues, like the number of Aubrey holes, mean nothing.
The fact there's 56 of them, well, there has to be some number of them. I mean, it's 56 because it happens to be 56.
Or perhaps we have vastly underestimated Stonehenge's astronomers. Was this monument really a sacred observatory?
Until we find written records from that era, if we ever do, or we build a time machine to go back, really we're stuck with plausibility.
But plausibility leaves open an astounding conclusion: that the ancient shamans were astronomers and Stonehenge their observatory. 5,000 years ago, their observations achieved a level not seen elsewhere in the world for almost 2,000 years. Perhaps they were the first to map the path of the sun across the year's seasons, the first to calculate the lengthy cycles of the moon, and even the first to predict the timing of eclipses. If so, the people of Stonehenge were our earliest space scientists, embarking on mankind's historic exploration of the universe.